Today we're going to talk about graphing parabolas. By the end of this video, you should be able to state the important pieces of a parabola, and you should be able to graph a parabola from standard and general form. First, let's take a look at our conic sections. To create a parabola, you would slice a cone on the diagonal like this, and this shape created by the cross section will be a parabola. So our conic section is parabola. And we're going to talk about two different types of parabolas. The first is the type that you saw in Algebra 2, which is like this or like this. And we're going to call these vertical parabolas because they open either up or down. And the standard form equation for this is x minus h squared equals 4p y minus k. The new type of parabola that we're going to take a look at is a horizontal parabola that opens either to the right or to the left. The standard form equation is very similar, except we're going to have y minus k squared, which means our y is being squared, equals 4p x minus h. So if you notice, for a vertical parabola, the x is squared. For a horizontal parabola, the y is squared. Some applications of parabolas are projectile motion, which you talk about a lot in physics. This would be throwing a football or launching a missile or any sort of thing that is flying through the air. And another application is light beams, like with a flashlight. Flashlights use parabola to help reflect the light. So now let's take a more detailed look at parabolas. A parabola is the set of points in a plane that are equidistant from a given point called the focus and a line called the directrix. So first of all, we have our vertex, and that's essentially the same as it was in Algebra 2. Then this point here is called the focus. And this line here is called the directrix. Now every point along this parabola is equidistant from the focus and the directrix. So that means if I pick a point on the parabola, then the distance from the focus to that point is the same as the perpendicular distance from that point to the directrix. So those two pieces are congruent. And that is true about every point along the parabola. So if I pick this point here, the distance from that point to the focus is the same as the perpendicular distance from that point to the directrix. So those two gray segments are congruent. Now we have a few more pieces of information that we need to know about our parabola. We also have points of symmetry, which are points that are horizontal from the focus. So these are called points of symmetry. Next, we have this distance between the two points of symmetry, and that distance is called the latus rectum. Finally, we have our axis of symmetry, which cuts the parabola in half and will always go through the focus and through the vertex. Now, let's look at the relationship between all of these parts of the parabola. So we have our standard form equation for a vertical parabola, and we know that the vertex is the point HK. Then we know that the axis of symmetry will cut the parabola in half, going through both the focus and the vertex. And in this case, for a vertical parabola, the axis of symmetry will be a vertical line, so you need to make sure you write your equation for the axis of symmetry as the equation of a vertical line, which is x equals a number. Now, the focus is a point, so you need to make sure that you write that as an ordered pair. But we need to know the relationship between the vertex and the focus, and that is that the distance between the vertex and the focus is p. So whatever number p is in your equation, that is the distance from the vertex to the focus. If p is positive, the parabola will open up. If p is negative, the parabola will open down. Next, we have our directrix, and the distance from the vertex to the directrix is also p. In this case, our directrix is a horizontal line, so you want to make sure that you write that as the equation of a horizontal line, which is y equals a number. Then we have our points of symmetry. And our points of symmetry are each 2p from the focus. Points of symmetry are points, so please make sure you write them as ordered pairs. Lastly, the latus rectum is the distance between the points of symmetry. So that will be 4p, and since it is distance, that will always be positive. So we're going to say it's the absolute value of 4p. Now let's look at some examples. Here we have an equation of a vertical parabola. We need to write all the characteristics and graph it. So first we need to find our vertex, which is the point HK. So that will be 3, 2. Then we need to find our axis of symmetry. The axis of symmetry is the vertical line that goes through the vertex. So that will be x equals 3. Then we need to find our focus. We know that the focus is p units from the vertex, so we need to figure out what p is. And if you look back at our equation, we know that this is 4p, so that means p is 2. Since it's positive, the focus is going to be 2 units above the vertex, so our focus will be right here at the point 3, 4. Then we also know that the directrix is p units from the vertex. So our directrix is going to be 2 units below the vertex, which would be here at y equals 0. Then we know our points of symmetry are 2 p units left and right of the focus. So from the focus, we want to go 2 p units, which would be 4 in each direction, and those 2 points are our points of symmetry. Finally, we need to find our latus rectum, which is 4p. So in this case, our latus rectum is going to be 8. So that means that the distance between the 2 points of symmetry is 8. And lastly, we connect all of these points to form the graph of our parabola. So there we go. All of those points should be equidistant from the focus and the directrix. Now, horizontal parabolas are a tiny bit different, but they are very similar to vertical parabolas. If you look at the equation, the y minus k and the x minus h have switched signs. Other than that, all of the relationships between the focus, the vertex, the directrix, the points of symmetry are all still the same. Your vertex is still hk. The distance between the focus and the vertex is still p. The distance between the vertex and the directrix is still p. And the distance from the focus to each of the points of symmetry is still 2p. If p is positive, the parabola will open to the right. If p is negative, the parabola will open to the left. Let's look at an example. Here we have our equation, and we know that this is a horizontal parabola because the y is squared. So let's find our vertex. Our vertex is still hk, but here's where you got to be careful. Some people mix up h and k because they're not in the same position as they were in the previous example. H is always with x, k is always with y. This time, since our parabola is horizontal, our axis of symmetry is going to be a horizontal line that goes through the vertex. Horizontal lines are y equals, so our axis of symmetry is y equals 1. Our focus is still p units from the vertex, so we need to see what p is. In the equation, this is 4p, so we know that p is going to be 3. Since it's positive, that means the parabola is going to open to the right. So our focus is 3 units to the right of the vertex. So our focus is 7, 1. The directrix is also p units from the vertex. So our directrix is going to be 3 units to the left, and it is a vertical line, so our directrix is x equals 1. Our points of symmetry are still 2p units from the focus, and they are going to be 6 units above and 6 units below the focus. Lastly, our latus rectum is the distance between the 2 points of symmetry, which is 4p, which will be 12. Now we can connect the points of symmetry and the vertex to create our parabola. And there we go. All of the points along that parabola should be equidistant from the focus and the directrix. Let's look at one more example. This is given to us in general form. We need to rewrite it in standard form before we can graph this. So we're going to have to complete the square. Now we can see that the x is squared, which means this is going to be a vertical parabola. So let's start with our x terms on the left and all the other terms on the right. Now we need to complete the square, which means we have to do b divided by 2 squared, which will be 9, and we need to add 9 to both sides. Then we need to factor the left side, and simplify the right side. Then we need to factor our GCF out of the right side, and then we can start graphing. Now we have our equation in standard form. The vertex is hk, which will be 3, -2. We already said that this is going to be a vertical parabola, so our axis of symmetry is going to be a vertical line through the vertex. So that is x equals 3. Our focus is going to be p units from the vertex. Since we have -8 here, that means that p is going to be -2. So since p is negative, that means that the focus is going to be 2 units below the vertex. We know that the directrix is also p units from the vertex, so our directrix is going to be 2 units above, which would be the line y equals 0. Our points of symmetry are 2p units from the focus, so we're going to go 4 to the left and right. Lastly, the latus rectum is the distance between the points of symmetry, which is 4p. And since it's a distance, we're going to take the absolute value, so that will be 8. Then we can connect our points of symmetry in our vertex to form our parabola. And that's it.